Welcome everybody to our 130th AiM Learn Fast webinar series episode. We've been doing these for quite a while, since March of 2020, and having a great time doing it with a bunch of folks that have really been enjoying watching them. I get so much feedback back and forth about the value that has been added from all the guests and the co-hosts that we've had, and it's been fantastic. So as of now, we've got them lined up, I think, for the next month and a half or something like that. And just so you know, we probably will be extending it and continuing on. I know some of you can watch these live, and many of the rest of you do watch them later on YouTube. Any links that we talk about today that we may put in the chat box for the live users will be put into the description on the YouTube video. Just if you get down there, you can't see them, just click on the show more button, and you will see everything that we're handing out into the chat box as well. So keep that in mind, and we're going to have a great time today talking about PDMs. We've got a great lineup today. We've got our good friend and AiM technician Robbie Yeoman is here. He's been a many-time co-host with us, presented information on CAN and high-tech stuff and harnessing, but he's always out there at the racetrack as well. He loves building those custom wire harnesses and chassis, and it's all great times with him. Thank you, Robbie, again for coming and joining us. I know you're super busy, and just happy to have you here.
I'm happy to be here, especially for Todd Buras's webinar. Me and him go way back, so it's nice to have him on here and talking about our new hardware line, because we met at the racetrack, so it should be a good one.
Todd and I probably met at the racetrack as well, probably in some sort of an argument over racing, right, Todd? I have no idea. I don't remember. I don't argue much at the racetrack, but Todd has been a friend for a long time as well, and I got to know Todd at the racetrack from Mazda Racing, and through Spec Miata, and maybe even a little bit earlier than that, possibly. But Todd is a longtime Mazda racer, national championship, the runoffs winner. He owns a company called 321 Motorsports that has been doing some installations of these PDMs and other things, obviously, as well. And it's his first time joining us here. So welcome, Todd. I'm glad to have you here, and we're going to have a good time today.
I look forward to it. And Robbie and I go way back 10, 12 years ago when I was running IMSA in Grand Am. And Roger, you and I go back even further to 2002 when I was racing with your son in the very first Pro MX5 Cup, which is now Global Cup. But yeah, we had 90s and 93s and 94s back in the day, 02 and 03 racing against Andrew. So we go way back.
The car that we had was a 1991 1.6, and I know you have made a few. Maybe you'll see some pictures a little bit later. You made a few attempts to bring the 1.6s back into the Spec Miata fold, and with good success. So I'm not sure anybody else has been able to make those NAs work like you have, and your driving is stellar, obviously. So, and we were actually teammates a number of times in the MX5 Cup, a few times, and we were able to even compare some data and had some good times doing that. So
in 06, 07 we were teammates, and your data, is amazing how the AiM back the day, we started with Stack in 03, and then Stack data in our stuff, and then went to AiM with the Mazda stuff, and truly incredible. That's a great
it's funny, we're almost spoiled now with electronic fuel injection and CAN, and like how many sensors do you have to run now? 2, 3? And back in the day, we were tapping into TPS sensors and running all of our redundant temp sensors just so we could collect this type of data. And now it's done with 2 wires, 4, I guess, power, ground, and CAN.
Well, back with the Miata on the screen right there, we still have 6 sensors: brake, throttle. Now TPS we can get from the TPS on the 04s, but everything else, brake pressure, water, we got to put a sensor in. So
gorgeous car that your friend Mr. Drago puts together there. I think that's who owned that car, if I remember right.
That is correct.
And what was it? What year was it? 2019 was it that you won the runoffs at VIR?
That's correct. Yeah, 2019.
Yeah. In fact, I've got some pictures here of some stuff that you've done. There's some stuff from World Challenge. Looks like a NASA championship. I think you didn't win that day. It doesn't look like, but at least you're not on the right. They messed you up and put you on the wrong step. Maybe that was it or something, right? But
he beat me by 0.004, so it was pretty close race. That's Coda. Yep.
Yep, I can tell by the cowboy hats there too. And I was there. I think I was standing not too far away from the camera. And then sports car was wrong. Always a shirt that is loved to be worn by many, because they always try to do the SCCA magazine tries to put something together and say who's going to win in each of the classes, and people love to wear that shirt, so that's always good.
Right.
Give us a little bit. You talked about Miatas and World Challenge and IMSA. Give us a little bit of background, even a little bit deeper on when did you start racing and what got you started? Did you start riding cars, or what did you do to begin with?
Well, I flew aerobatic airplanes, actually. Built and flew them from scratch when I was 19, 20 to 26. And, it got a little dangerous, so I stopped flying airplanes and started racing cars. So at 30, I made the change, ran a little bit of roundy round for a year or two, and then got hooked up with SCCA, and it was kind of over after that. So in 2003, I bought into OPM Motorsports. We built our first spec Miatas and ITA, CRXs and Oldsmobile Achievas, Kermit, and started racing spec Miata in 03, 4, 5, and then moved on to the Global Cup and quickly into IMSA and World Challenge with lots of different teams, Piper Motorsports and IMSA, and then Irish Mikes with World Challenge and Grand Am at the time. And doing data, basically, we were using Motec and we were using AiM, and still ran the Global 5 Series, what it is today, through 2012. And then Grand Am through our World Challenge through 17. So yeah, so it's been a started at 30, racing cars at 30, so that's kind of late, but was blessed that did well, always did well, and came back with a clean car, and it's been a great journey.
And you've been a successful businessman down there in Florida, and done well with that. You're just a talented guy on all sides. So, likable and fun and way quick out there. I know just from sharing data and looking at what you can do. You can throw some stuff in there. You're certainly not scared of jumping in the car and going for it. So that's it's always been fun to watch. So I've always appreciated that.
And I appreciate the business. We had a very successful Krispy Kreme donuts for 20 years, and we sold our franchise recently. We were the largest franchisee, and we sold it, and it's allowed me to move on to 321 Motorsports.
Yeah, there you go.
So 321, I have a lot of acreage in Florida, and we have a big barn out back, a really nice shop, and a close friend of mine, Jeff Linford, and I decided to start doing AiM PDMs for customers and customer cars. At first, we were like, wow, we need to buy a screen anyway. So what's this PDM all about? You get the PDM, and you get the 8-inch screen and a 8-inch, an 8-plug Marine 8, and started, the first one we did. We've done 5 of these units so far, and the first one we did was for a Champ car. And listening to some of your awesome webinars, they kind of really raised an eyebrow, and so we started diving into this.
You mentioned to me as we were chatting the last couple of days that some of the ideas came to you from just joining in and watching these webinars occasionally whenever you'd have a few free minutes, and you some of the times you were watching Robbie up there talking about them or doing some different things, and you go, well, wait a minute, we could do that as well. We got to put dashes and displays in these things anyway, so maybe the PDM is a better way to go for us. So tell us a little bit about how maybe how the webinars helped you get going.
Well, when we saw the first PDM, we really didn't know what it was, power distribution model. What does that mean? And a friend of mine, Jeff, understood it right away and said, we got to get one of those, but to get one, we had to submit to Robbie a profile of what we've done in the past to say we can support it. So we were blessed enough that Mike was able to, sell my friend Louis Bustani one, and we put it in the car, and we had wires going everywhere. We were like, it was a disaster, but it worked. Our Champ car worked. We were blessed enough to run and win 7, 8, 9 in a row in a Mazda Miata stock ECU, and not a stock ECU, but the PDM. And it's really been it's been a blessing. And as we've learned from Robbie and your webinars on what it can do, it really becomes what the imagination will allow you to do in programming. So it's really become cool.
Yeah, you can really circumvent a lot of physical things that you would normally fix physically. You can program around them. Great solutions for turning on lights, and I think you had a couple of those stories where you.
Oh, absolutely. No, and what's really great is the Marine 8 that attaches to this, because it uses the CAN bus high, and it's a 8 switch. You got a momentary, you got toggle, or you got, just a quick click, which takes away a lot of wiring, and it's easy to program. And it, just one button clicks on and clicks off. And, you got 8 buttons that all light up in aluminum when they're actually working, or problems that will come arise. But, so yeah, we built a K24 swap. We did a K24 swap, and we do headlight to tail light wiring with Tefsel and Tefsable expandable braid, Teflex loom, and wire wrap, and do everything with Deutsch gold pin connectors. So we use really high-end stuff for our wiring jobs, and really wire everything. And started to learn that in the top left picture here, you'll see the spreadsheet that we come up with. And if you zoom in on that spreadsheet tells you what plug it went into, what color the wire was, what gauge the wire was, what the function of that wire is. So when you go to program at the end and you've got 32 inputs, it becomes as quick as you can, as quick as you can do it, you can turn it on and make it work. And this past weekend, we were driving this car, this K24 swap in WRL. We were fortunate enough to finish second, but for the last hour, our brake switch died. So they didn't bring us in, and they basically gave us a warning and said, hey, look, your brakes aren't working. Fix it before tomorrow's 8-hour race. And basically the switch was 30 years old. It had died. And we were trying to figure out how to make it work. And I was like, well, wait a minute, when you're off throttle, let's just say if you're 5% less throttle, the lights come on. And we were able to program that into the PDM in about 5 to 10 minutes, and then just upload it into the dash. And when you're off throttle at, 5% or less throttle, the brake lights come on. So,
I mean, that just seems like a huge time saving. You're not going to have to pull out the brake switch, put a new one in, or troubleshoot the wiring for that. It's just a simple logic thing. Gets you back out on the track immediately. It'd take 30 seconds to send the config, a couple minutes to build the status variable.
Absolutely. It took a couple minutes to build the status variable and switch. And the neat thing too is we're using the 200-watt capacitors. You can't see it, but it's up underneath the dash, and it's what they use in RVs now. And if you see these 2 little switches, one is on the airbag sensor, and then one is to the left of the Marine 8. So that's what IMSA uses, right? And those are your kill switches for the car. So those 2 little switches, you can put them all over. You can put them on the front dash. You can put them on the back.
And they're mandated by IMSA, correct?
That is correct. And SCCA just adapted them for kill switches, because that goes to, and I'm not sure what it's exactly called, but it's a 200 amp solenoid that you can kill and turn on with that.
Like a battery isolator, like pulls the battery completely from the system. That's
correct. So you click that switch up, turns on the solenoid, and then it fires up the PDM. The dash will come on and everything fires up. And then the Marine 8 will come up with that. Then you click the ignition panel for the Marine 8, and that will fire up the ECU. And now you got power going everywhere. It's like your first click on a normal key, right? That is correct. Yeah. And what we did, before we had it on just the main switch where everything would fire up at the same time. Well, if the PDM would fire up before the ECU, you get corrupted data. And we're like, okay, what's going on here? Well, we realized we need to fire up the PDM and get the PDM and the dash all up before we fired up the ECU. So it would actually read everything. Otherwise, the data would work sometimes, but then 10, 15 minutes into the race, it might die. The car would freak out and you'd have to fire it up again. So we figured out that quickly, because we were using the CAN bus bilingual, right? The CAN bus high was bilingual, talking to the ECU, and they're transferring data back and forth. So we figured out that, okay, fire up the PDM first. Once that's up and running, then fire up the ECU. If that could be a stock, if we could make that a stock thing without having to hit the button, that would be great. But it works that way.
Interesting. I got a couple of pictures here that maybe we can go back, and I think you told me this was like your third install. And and when I think of Todd Buras, I always think of the BSI orange car. So I use these pictures specifically. But what you're doing here is you've just got the PDM mounted over here in the passenger side floor, and you've got the wires pretty well cleaned up. You told the story a moment ago of there being a the first couple. You hadn't got the handle on routing of the wires, making them clean, all of the things that happened. This one to me looks fairly clean, but you mentioned that even the fourth and then the fifth ones have been getting better and better as you just learn more and more and what doesn't need to be there, right?
You're absolutely right. The first one, wires would come out and take a 90-degree turn and go right over the PDM, and it was a disaster. The second one looked a little bit better. Wasn't on a panel like this. One was mounted to the side of the tunnel. The PDM was up, somewhere else. So wires were going everywhere. And as we've done 5 of these installs now, and we have 2 actually after this install. We have one of the BMW Motorsports America STU cars out there, Irish Mikes, and then another one coming in after. But what we're learning is that as you can see, the closer they are together, the neater it gets. So the TepFlex loom and the wraparound has helped us out a lot in this stuff, and that's that. And then the stuff coming from the back has really helped us out in the way that we do it. And the way you think about this is a tree trunk, right? So if you were able to put your power and the fuse panel the negative ground there to the left of that panel, and you put them all in line and run it up the tree trunk, then it just becomes neater and neater and neater. So the fifth one, the one we're doing now, is just all in line, no wires going anywhere, and it's just really attractive. But it's taken a long time to get there.
On that plate, you have the battery cable coming in. Is that a thermal fuse for protecting the power wire?
Correct. It is a thermal fuse. Yep.
So ideally, if it took a break or a nick or something like that, that thermal fuse is going to pop without like a dead short to the PDM.
Correct. Yep.
Yeah. It not only does it look better, but of course it keeps them getting scuffed up, as you mentioned. You talked about this plate. Miatas get real hot right there, and what have you done there to try to try to keep that cooled off and be able to clean underneath it and stuff like that?
1-inch isolators. So the 1-inch rubber isolators have 10
silent blocks. Yeah,
correct. Yep. And what we found is the silent blocks there, and what it is, and we keep the PDM straight for the lat long and some of the other stuff, and the signal comes in beautiful. So the isolators really do
dampens the high frequency stuff that you're getting
absolutely
on the accelerometers, right?
That's absolutely right, and it comes in beautiful. Some of the best data I have is from this particular PDM style here. The first one against the tunnel sideways, it didn't give us very good data, but as we've developed it, you see where it is now, and it actually really works well, a lat long and some of the
no doubt, and I've actually seen some of the data. It looks very, very good. But a PDM creates a good chunk of heat already. So having it isolated up off of even the plate, and then the plate being isolated from the hot floor is good for everything, right?
That is correct.
Yeah, it does a nice job. Peter mentions in the chat talking about securing the cables. Even you've done a nice job of connecting everything down. It looks like you got it zip tied and probably some other clamps in other spots. But boy, getting it all tidied up makes it all the difference in the world for chasing some problem down.
Yeah, troubleshooting. Troubleshooting a nest of wires is difficult.
Very, very, very ugly.
I think we've all been there. Open up the lid and you're just like, oh no.
I've got a couple of questions here that maybe we'll feed in, and then we'll come back to some of the other things. But Jeff asked a question that we've actually chatted a little bit about even before we started. But the sounds like your power up sequence could be an issue, right? I mean, if 10 or 15 minutes later you've got a problem, what if you spun or stalled? Robbie, maybe you can handle this technically. Is there a way to delay the ECU starting up after you fire up the PDM, since it's automatically starting the process?
Yeah, absolutely. Status variables. So whenever I need to, let's say, prime a fuel pump or put a delay onto a power output, you can use a backwards logic. There's a channel in the PDM called safe ignition, and when the ignition pin is energized and the PDM is on, that goes true. So you can say when safe ignition is true, then I want to do something. But you put a verified for, let's say, 5 seconds. So at PDM turn on, the safe ignition is technically false because it has not been verified for 5 seconds, and you get an initial wait period, and you can play around with the times. So it's basically creating a status variable to the negative. So I want this status variable to be, when this status variable is false, then don't power it out. When it's true, then send it power.
Perfect. And what Todd has done, if I jump over to this one, and you can see the Blink Marine, control panel, what he is, the workaround that they came up with to make sure this didn't happen is he had a button to start up the AiM device and get everything in the PDM, everything up and running, and then a second button that actually started the ECU and started the start sequence. So if it died, you would end up only pushing the second button. But there's an automated way of doing it that Todd will probably go back and start working on this afternoon, probably.
Absolutely. I'd love that 8 button. I'd love to have that button free and not have to hit the ignition,
Right.
and just have it part of the startup ignition system. So
I like to take the driver completely out of the equation, if possible. Just automate as many things as I can, because you have other things to worry about. You're getting in, you're prepping, you're trying to focus, and the last thing you need to do is go through a laundry list of buttons and things to go through to get the car running.
Or even worse is the example he got. You just got tapped in the corner and spun out and killed the car, right? You're probably not going to go down your checklist and start pushing buttons. Todd will get a little steam coming out of his ears there, right? And maybe push the wrong buttons in the wrong order. So anything we can do to make that a little bit cleaner and easier is probably better.
Mm-hmm. Yeah. There's a couple of questions if I could address them.
Yes, please.
Liam. The blinker, we should probably talk about that in a more controlled way. I got a lot of questions to ask, but feel free to reach out to me. I'll be more than happy to answer them. But the second question, is there a plan to add diodes to all the power outputs? That's actually already done. The hardware itself has freewheeling diodes on all power outputs, and it has a series diode on the high power 1 for starter solenoid activation or tremendous inductive load. And so we have already taken care of it. The checkbox that you see in the power output configuration is to enable or disable that freewheeling diode. So you'll notice that's available on the power output channels.
Some of the very, very earliest ones,
first 50.
Didn't have that, and maybe that's what you're seeing, Liam, or something like that. But maybe get a hold of Robbie and chat about that, and make sure we get that figured out. So, you see anything else there, Robbie, and any of those other ones in there? You guys are asking some good questions, and I appreciate that.
There's
great
some
questions.
Really good questions.
Yeah.
Great questions.
Absolutely.
I mean, so Robbie, you could probably help me with this, but one other things we started doing is not only the back and forth communication, but we're taking processes away from the Megasquirt 3 processor, turning on the VVT and the VTEC at different ranges of the RPM with the PDM. So when you're using a 36-2 wheel coil on plug or whatever it is, it's processing a lot of information there. It becomes, you're taking processes away from the ECU so it can do its job better. And then the PDM is taking over these other processes that are easy on-off switches, so like at a certain RPM range in this particular K24 swap that we did, we have the PDM turning on the VVT, and then we have it turning on the VTEC. So it took process, and we found that it's working great. We just ran the 8-hour enduro at WRL at NOLA. We finished second the first time the car's ever been out, and it never missed a beat. So it seems to be working great.
That's fantastic. Yeah, anything you can do to split the computational load is fantastic. I mean, from our standpoint, the processor that we put into the PDM 32, it's a workhorse. We still have lots of room to grow and
of head
develop.
space, huh?
Yes, absolutely. So yeah, feel free, throw us all the stuff that you want us to do, and then even from a logic standpoint, you can take this simple switch and you can, in the software, you can create a working mechanical multi-position switch from just a standard momentary. So if I have a switch that is normally off at rest, and when I push it, it goes to on, I can make that a momentary like it is mechanically, or I can turn it into a toggle. So I just hit it once and it latches on, or I can set it to a multi-position. So I tap it 2, 3, 4 times to get different, and it's not mechanical. It's all done in the software.
Brilliant. I mean, it really is just brilliant how, you just don't remember how many buttons and what the button does because you can only put one sticker on it. So
Right.
It's kind of, it
Yeah.
gets kind of tough to remember what button it is, but we have override for, you can't zoom in on the buttons there, but we have override for the fan. We have, the windshield wipers, and with the half bridge, you can make the windshield wipers actually work. And that seminar you did on that was great. To get it to actually turn off in the right spot. A little bit of programming, but it works.
Yeah, Todd, let's talk about this picture that I've got up here. I'm going to take these pictures down here in a minute. We'll go full size and we'll talk some more. But you put the K24 Honda. You took that whole engine and all of its electronics, and you've talked about it a little bit already here this morning. But I just want to talk about why this was such a complex and exciting PDM install, because you took that whole piece, you pulled the Miata motor out, you put this K24 Honda in it, and then you stripped, like we're showing here in the upper image, you stripped the wiring harness out of anything that was not needed, basically bumper to bumper. You pulled it out, and then you had the PDM handle everything. One of the ones that you told me about, and maybe you can expand on it plus some more, but you had the stock Miata dash still in there, and you had an MXP up in front of it, or maybe you had a dash by that time, but it was running everything. It was running the stock speedometer, it was running the warning lights, it was running the everything, right? All ran through Absolutely. The PDM. Talk a little bit about how the complexity of that install, and clearly it's worked really well with many hours in endurance cars.
Yeah, this was a K24. The gentleman that we built this car for, the customer, bought the ultimate K24 swap kit. So he got the front bar suspension, bought a $600 K24 motor, put it in, and the car came to us with the drivetrain and the motor in it. He sent us a complete Miata 2004 wiring harness. East Street Racing actually did it. Put it in, and we took every single wiring out. Now, one thing he did was he put in the ABS from the 2004 model, so the bigger suspension sport brake package. And what we did is we took we built a wiring harness on the engine from scratch all the way to the back, and we took the main Miata wiring harness apart to pull out the wires that we needed for the 4-wheel sensors. There was 5 different powers, 1 main, 1 ground, 5 different powers for each sensor, and we integrated it into the PDM, and it was a single logic for the ABS unit to fire up, and ran it through the PDM. So we were doing multiple things with multiple brands. This individual, Jeff Linford, was able to go to the schematics of each of one of the wiring harnesses and pull out what we needed and program it in. And when we were done wiring it, what you see here in this bottom screen, and you see this to the top left here, we fired it up. We turned, as Robbie said, the first time you hit the ignition switch with the power on, you're just praying to God you don't see smoke.
Smoke, or everything goes as according to plan. Yeah.
Yeah. I mean, I should send you the link to where the first time we fired it up, we hit the ignition switch, and the dang motor fired up, and it started running the very first time. No tuning, no nothing, no timing. We just threw some Marvel mystery oil in the top of the K24, the $600 junkyard motor, And you know, it smoked a little bit, but it fired up and ran straight away. Developed 100 foot-pounds of 100 psi of oil pressure, and you know, we started tuning from there. But the very first time we hit the turn switch, we hit the ignition switch, and we hit the start switch, it fired right up. We took it down the street after, you know, 15, 20 minutes of tuning, and it was kind of rainy that day, and I slammed on the brakes and the ABS worked. So I was
Fingers
like,
crossed.
oh, are you kidding me? You know, 100% working. And if you bring up that video, you know, I'll send a link to the video, or Roger, you have it.
I have it, yeah, on my phone.
You know,
Yep.
if you send a link to that video, you can hear it in my voice. We took, you know, 3 different manufacturers of stuff and made it all work. 4 actually, the Mega Squirt, you know, the AiM PDM. We took
Honda and
K24 Honda, and we took Mazda, and we made them all link up and work, you know. It was pretty exciting when it happened, because you know, most of the jobs that we do are 7 to 9 days. So this complete K24, you know, headlight to taillight wiring job took us 7 to 9 days before that, you know, and we street tune it. Then we take it to the dyno and we dyno tune it, and we delivered it on Thursday. The guy took it to the track on Friday, and I'd love you to read the email, you know, the text he sent me. You know, we took it out 4 times, and we kept waiting for the big drama to happen, and it just worked flawlessly. You know, it worked from the word go, you know, and we integrated the radio, so the radio comes on when you turn on the power, and
Cool.
so pretty cool. You know, the PDM is just incredible when you really start to understand what it does.
Robbie, you've had some pretty complex builds, as well as you've been learning more and more about these things and becoming one of our best experts. You have any stories of stuff that you've done?
Well, actually, I did want to talk to Todd. So after getting your first PDM under your belt, how much time do you put into developing the harness? So like basically from start to finish, from connector to connector and turnkey, like how much time do you think you have just in the harness alone?
Oh, schematics.
Yeah. I mean,
The
planning,
schematics, yeah,
planning,
and building.
physically wiring it, and turning on the PDM.
What's really amazing, Robbie, you know, the first one we did, it was a Champ car. It probably took us 14 days to do it. The second one, you know, 14 days, 8 to 4, you know, just kind of figuring out wiring and schematics and underneath, and taking it from the headlights, running it in, and kind of trying to figure it out. The last one we did here, you know, and that was a triple. It took us, we got the car in on a Monday, and we were done by the next Monday. So working 6-hour days on it. So we had about 4 or 5 full days of 6 hours, and then turned it on, and it worked. So we've got it down. We got it down to a science. We really understand what it takes. You know, now we have all the correct wire, the color wire, the plugs, all the crimpers, you know, and I'll be working on wiring while Jeff's working on the schematics, and it's a symbiotic relationship. By the time it's done, you know, I'm laying everything out and bringing all the wires in. Then we start crimping that and plugging it into the PDM. And the key is, you know, this little picture to the top left, Roger, if you know, of me smiling, and you can see Jeff in there.
Yeah.
You can see Jeff's back in the car, and he's yelling out, red 18, you know, going into B24, and that's the rear lights, you know, and it takes 2 people to really get it done at the speed we're doing it. So it's definitely not a single person project. It's a dual person, and we both have to be on the same page.
On that same question in the chat box, John asked, are you doing most of that work leaving the harness in the car, or do you pull it all out, lay it out on the bench, do some work there, put it in the car, and start to connect things? How are you doing that?
Well, what we're doing is the very first picture where you see the wiring harness here in the top right. What we've done, that's actually a little bit different build. What we'll do is, if you go to the other page, the CRX, see how it sits in the car. So what we'll do is we'll start with sub harnesses in the back rear lights, and change out every single plug, every single connector, and run single wire loom all the way up, and kind of gauge the wire. And then we'll go to the back and say, okay, this, you know, 9 feet, and we'll kind of do it in the car, to be honest. We'll run it along with very loose zip ties. Yeah, very loose zip ties. And we'll start in the back by the lights, run it all the way up through the chassis where you see it come in on the right picture. and then just leave no connector, but enough to go up and come back down, kind of like a tree trunk. Like I said, if you think of a tree, all the branches are at the top, and the trunk is all the wires coming down into the ECU and the PDM, and then leave an extra foot in case we screw something up. And it's all single line connectors with all single line lines with new connectors at each one of the switches.
So
And
from a builder of cars, would you say that this is an easier wiring than a standard conventional fuse box relay mechanical switch install, and you spend more time on like the programming of the electronics, or do you think this is a harder installation with the electronics on board?
oh, absolutely, it's easier. The There's so many less. I mean, we're figuring out to run less and less wires every single time. If you can zoom in on the CRX, we have so few wires in there. It's becoming less and less every time because we're figuring out the PDM can do that. I don't need to run from the lights to the rear brake connector switch back to the PDM. So that's -1 wire. That's just one example. And we're just figuring out it's less and less and less wires because we've stopped. We ground in the back, and then we also ground right there. It just depends on where we need to ground. So we're figuring, every time it becomes less and less wires. It's so much easier. To answer your question, it's so much easier with the PDM once you understand what the PDM can do.
And you have that new skill you have to learn about how to, to program it and all that. But the physical wiring is way easier, clearly.
Absolutely. I mean, if you can think of like you have a relay for a fuel pump, you have an excitation wire and a pass-through wire, and then you have the supply current, and you have a ground for the relay. So that 4-wire package is now done with one throughput wire from PDM to fuel pump, and you go in and program it the way that you want it to turn on.
You said that perfectly. I mean, it becomes 2 wires to the fuel pump. It's truly incredible. 2 wires to the fuel pump.
It's because I did it. I've done it.
Because you've done it.
We've done it a ton too. I mean, it's just incredible that you're getting rid of so many wires. And the brake lamp switches, the brake lamps, they're 2 wires to go to the brake lamps. As long as you have the schematics to understand power and ground, bring them to the PDM, they work. They're brilliant.
Yeah, Peter Krause makes a mention, and David agrees with him that you have to have the end in mind before you crimp the first connector, right? You start to plan it out and have everything kind of laid out. It makes that so much easier to do it correctly, I suppose.
Yeah, design comes first, 100%.
Design comes first. You've got to plan it out and design it out, and that's what we didn't do in the first 2. Yeah. And then the third one, I was like, all right, time out. Let's start over.
We must design this first and set it on the fly, right?
Yeah.
But Tice has a kind of an interesting question there that do you run the push to talk radio button over the PDM with an in-out input? His second part of that is it's a great way to diagnose driver errors in the data. He can be, if he's pushing the button and he's talking about something, it's actually making obviously recording that the radio is being used. Have you ever done the push to talk radio part, or are you doing that just through the radio?
Usually.
Radio.
Yeah, for me it's a pass-through wire. So like I may receive it in on the Pro 4 truck that we wired up. It was part of the steering wheel mechanism, so I could track it when he was on the radio and when he was off the radio through the wheel itself.
Okay.
But in my normal builds, it's just a pass-through wire, even if we have steering wheel button control. I haven't actually logged it. It's a great idea. Say, hey, quit talking to me. You need to focus on racing. See how much slower you're going?
Yeah.
Or something happens and he's pushing a button talking about a problem. At least it'd be marked in the data where that that there was a problem that happened, not necessarily that he was driving poorly. The driver. Yeah, exactly. You see any other questions in there? I like the one from Ace there. I don't know if you've seen that one, Robbie. That one might be one that I'd like you to answer. Can you use the PDM to control a fuel pump via PWM, pulse wave modulation?
Pulse width.
Width, I'm sorry.
Yeah, you can. It's a bit odd because we haven't given a dynamic pulse width modulation. So you have to essentially bracket your fuel delivery. So if you wanted a 80% duty cycle at or at 80% throttle, then you can build a bracket for that and say if it's over 80%, give me 80% duty cycle. If I'm at 100%, give me 100% duty cycle. And you'd have to pair it. Ideally, to run a fuel pump, you would want it to be much more dynamic. You don't want 6 or 10 bracket points. Every 10% we bump up the fuel pump. I'd like it to grow naturally with whatever supply channel I have. So in the example throttle position, if I'm at 66% throttle, I would want 66% duty cycle on the fuel pump, or some relationship
Variation
between
of
those two
that.
things. Yeah. So while it's not quite there, the hardware is more than capable of doing it. And in fact, we use pulse width modulation on tons of other things. It's just there's no dynamic nature to it at this point.
Walter has a question. They're talking about half bridges and full bridges. Can you give us a brief overview of what they do, where to use them? He says he does not understand it from the manual.
Oh, well, a half bridge is one half of a full bridge. So to create a full bridge, it requires 2 half bridges. So it's pretty intuitive on that side of things, but how would you physically wire it up? Well, you have to sync current and supply current. So in a wiper control, and Todd, I think you run wipers on your cars, right?
That's correct. Yep, we do.
On the wiper control, you have to take a half bridge power output and run one side of the motor, and take another half bridge power output and run the other side of the motor. So there's 4 wires here, and what you're going to do is alternate the syncing and energizing of current through the motor. So when one half bridge goes low, then the other half bridge goes high, and now we're pulling the wiper back, or vice versa. We switch the power delivery, and now the motor's going forward, and you have to walk that balance between with the park signal to push and pull a motor. It's not as common as you would think. Older style motor assemblies, they require it. But most new cars, they have what's called like a smart solenoid. So you just energize it with power, and it has a park signal, and all you have to do is send it power, and when it sees the park, it stops.
Much easier than the older ones, right?
Right.
I know that's always been a problem for PDMs, and I don't know much about them, but I always see that's always been a struggle for folks. So that the newer motors would be helpful.
Right. Or streetcar applications, you have a electronic window that you want to go up and down. That's the same type of installation. It's a 2 half bridge outputs to create a full bridge.
Perfect. You see any other questions in there, Robbie, that you want to tackle? I haven't been able to scroll down through them yet.
Well, there was a question. I think it was from Liam, oh no, it was from Bruce. Bruce, having an issue with or is there an issue with crank triggers and cam triggers when you're sending heavy amounts of power? Absolutely, there is going to be an ingress into these types, but that's why we use a dedicated wire type, something with a shielded jacket. And the PDM has 4 ground pins that you can actually ground to for reference, so to bleed out any type of noise that it would be getting. So the idea is leave it open at the sensor end, run the shielded wire through your harness and to the PDM. Or to the ECU, and then you take the shield and you ground it to a reference ground of the ECU. And the idea is that any type of interference that it's going to be getting is going to travel on the outside of that shielded braid, and we're going to discharge it safely to a reference ground of the ECU. So there's absolutely, you will get interference, but if you take the planning precautions and use the correct wire type, then you should be able to navigate around those.
Interesting. The one last thing I would like to chat about a little bit is the harnessing. I know here at AiM we in both offices we've got folks that are building harnesses to spec for folks, and I know Robbie, you've done a lot of them in the off-road world that maybe even a little bit of an assembly line for a certain brand or something. But what do we do? What do we offer as far as harnessing for somebody that doesn't want to do that in depth of a thing like that? I know you've talked about it in some of our previous PDMs. You joked about it from napkin to the harness,
The
right?
harness, yeah.
Give us a little bit of background on what we can offer for people for harnessing.
We offer full turnkey solutions, all the way from a universal harness, which we have them for the PDM 08 and the PDM 32, and they're just loose wires that are we done the job of harnessing out the analog channels for you, because that's one of the stumbling blocks for most people. So we've harnessed out all the analog channels, all the speed outputs, the CAN outputs, and then we provide all the power outputs as just loose wire with enough length to get them to where they need to go. So the idea is you put it in the car, run your wires, cut them to length, add your connectors, and you're now just programming. So everything is much easier. It doesn't require a whole lot of planning, but the downside is you have lots of wires. You're not using 32 power outputs, but you have 32 loose wires, and they need to be taken care of.
And a big piece of that is then stitching it all together to make it all work correctly. Last week we did and we did these two in this order on purpose, right? These two webinars. Last week, give us an idea of what some of how to tie these last two webinars together. You explained a few things last week, leading up to having Todd join us on his experiences.
Mm-hmm. Some of the things that we get a lot of is CAN keypad integration. I have a tire pressure monitoring system, and I have a keypad, and we're out of CAN buses, and there's a lot of different ways to solve that problem. And we did the webinar last week, which is one of the ways to go about managing that. And it just comes down to forward planning. There's a problem. We just need to think of the solution. Some of the CAN integrations, like why do we use a blink marine keypad? We use a blink marine keypad because it has like a nice, well documented CAN architecture that we can follow, and we can build into the software a user interface. And I touched on this a little bit in the last webinar, but essentially the keypad is just a momentary control. You press this button, and however long you're pressing it, that's sending the data string to the PDM that says this button is pressed. When you let go, it's off. It's our responsibility as the PDM or whatever's controlling it to give it the function of the button. So is it a momentary? Is it a latching? Is it a multi-position button? We also have to do the keypad lights. So we need to tell the keypad that, okay, if this happens, turn the LED red. If this happens, turn the LED green. If this happens, turn the LED white. And it's all on our responsibility. It's very difficult to build that in using CAN output or for an end user to do that. So we took the Blink Marine structured, organized data set and built a user interface tool in the software. So we could do it with other manufacturers, but we would just need essentially documentation. The Blink Marines work incredibly well. The Gray Hills are they're used. They're very common, but they have a I like the haptic feedback almost of a Blink Marine keypad. There's a definite click, and there's like a finger recognition. So there's a divot in the button. So when you go to push it, even if you push the side of it, your finger kind of goes right to the middle. I don't know if you noticed that, Todd.
What now? I mean, I'm agreeing with everything you said, but what was the
the feel of the keypad.
The keypad, how it has
that. It's amazing.
Yeah,
it's
it has
amazing.
that like recessed input. So even if you're driving, so you have to take a hand off the wheel and sometimes navigate your finger to the keypad without looking at it. So you almost have like another sensory, a tactile sense that you can find the button and hit it in the center because it's concaved.
It's amazing. The Blink Marine is that we haven't got one that's been bad. They've worked. You can set them, and it just takes so much time away from the actual build because you don't have to run power and ground to every one of the switches and run more wires.
So Demetrius has an interesting question, and I don't know if you've used it, but do you have any parallel outputs, multiple power outputs driving something that requires a larger amount of amperage in your builds?
Yeah, we actually did with the K24 steering. It's a 9-pound electric motor for the steering rack. I don't know if you've heard it. It's K-Power. It's the new steering racks. They're electric, and it's electric assist down there. And they were, boy, I don't remember, but we used a full bridge for the power for that. It was pretty heavy, and they actually had it wired directly to the alternator, and we changed the way it was wired. We took it to the PDM, and then we put it on the solenoid, one side on the solenoid directly from the battery, and it worked much better.
So essentially all you have to do is either duplicate your logic or create a
Correct.
point to. So you have two
Correct.
power outputs,
Yep.
and the idea is to get them both to turn on at the same time. You could do it by writing the same logic for both power outputs, or you can actually write the logic for one and then point the second power output at the first power output and say, when this turns on, turn on this one.
That's correct. That's what we did actually. It was a big drain.
Yeah.
You know, also when you're running, well, some other neat things that, you know, just real quick, data logging with the PDM. When you're running enduro, taking it away, you know, if a sensor goes bad, well, you know, you saved your motor. But oil pressure falls below a certain number at a certain RPM, we kill the coil. Water pressure falls below a certain number at a certain RPM, we kill the coil. Kill the motor before it just dies, because it can react instantly. And if you bring it in and you have a bad sensor, well, you know, sorry, it took you out of the race, but you saved a $20,000 motor.
Right.
You know, we're starting to do that a lot with the PDM, even in some of the sprint race applications. But you know, it just reacts, or it tells you, hey, your oil pressure is getting low, and if you don't do anything about it, you know, it just kills the coils and kills the car, or kills the fuel pump.
Yeah. So Kyle had an interesting question.
Yeah.
Can a PDM apply logic to an input and output at different voltages? No. It's got an unregulated voltage that's being pushed through it, and we're telling it when and how to turn on. So it really comes kind of driven by the charging system. So I can't give you 5 volts. It's not regulated. They're depending on what you're connecting to, and I don't even know if I would go this route, but depending on what you're connected to, you can pulse width modulate the voltage, and you get a net output effectively of say 7 volts. It depends on the motor that you're working with. If it needs 7 volts regulated, you can't do that. But if it's an older piece of tech, then you may be able to get away with it. It might not be looking at voltage at such a fast rate.
One thing we did, and you might be interested in this, Robbie, was in the CRX. This person wanted to use the speedo, but we didn't want to run the cable. So the PDM GPS speed did a math channel to make it something that the Megasquirt would read, which was meters per second.
Mhm.
So it did a math channel over the CAN bus, sent it to the Megasquirt. The Megasquirt received it, turned it back into GPS, and then we PDM'd it to a DC motor, PDW, to a DC motor. And then we did, 50% or, 40, 60, 80, 100, and then kind of fluffed it. But the duty cycle for the DC motor to keep the speed relative to what the PDM sees. So it was pretty neat. The PDM worked really well for that.
Yeah, virtually the same thing you just talked about, Robbie, right?
Absolutely.
Doing it that direction. Yeah.
Yeah.
Very good. Very good.
And we didn't even know it would work that way, but we saw one of your webinars. You know what? Let's find a DC motor that runs at this RPM, and it will take the PWM, and it actually worked. It was like,
Awesome.
well, hey, we're going 10 miles an hour, 20 miles an hour. So, and it's reading from the PDM. So it's really cool that it actually worked.
And Todd, you made mention a second ago of that sensor telling you that the oil pressure is down, and you just shut off the motor. Of course, we always still have the option of it started a bit of a chat over there in the chat box. Of course, we still have the option of just turning on a light, or flashing some LEDs, or changing the display on the dash of low oil pressure. But you have just chosen to as a driver, you probably understand it, right? You've chosen to take the driver out of it, just shut it off. So instead of I think it's a bad sensor, I'm just going to keep going, right? So
that is correct. And that's what's nice about an old analog oil pressure gauge or water pressure gauge, that if a sensor does die, hey, that's why I said it's like one of those things, right? Do you lose a motor, or do you lose the race? So we've decided that I'd rather lose the race than lose the motor.
Although I'll tell you, I've had pre-electronics, when I was racing some off-road stuff, we just had an oil light, right? And that light just came on one time, and I thought, that can't be that can't be right. I mean, normally it would flicker, and we didn't have a gauge, but normally the light would flicker a little bit. So I said ignored it, and boom, it went right. And and it was an old Volkswagen air cooled, and it had sheared off the oil pump drive, and it was just like the sending unit went bad, but it hadn't. So it's never a perfect world. You gotta pick what is the right
Pick
thing
your battles.
for you.
You gotta pick your battles.
Exactly. Yeah, it set me back about $100 brick. Exactly. Back in when I raced, it was a whole lot cheaper. So perfect. Well, we'll start to kind of wind it down. Robbie, do you have anything else you'd kind of like to add on the technical side here before we jump out of here?
Oh, there was a lot of questions that we just didn't get to. Liam,
exactly.
I'm happy to help. I don't know if this is the right place to talk about these. I just have a lot of questions that would follow-up questions. And
Liam did have some great questions, but they were pretty darn technical that I think we would have taken up a lot of time to get to, and everybody else wouldn't have been as interested as you as Liam. So let's get together.
Yeah. My information will be at the end of this presentation, and feel free to reach out to me or the guys in the UK, the AiM Technologies. They're also sharp individuals. But he has an interesting question, and absolutely you can do that. You pulse width modulation of 21 watt brake light, and now you have a normal running light and a brake light in one.
Dang,
and it's a great, interesting idea. What you will get is a dimming effect. So your running lights are going to pulse ever so slightly. They're going to rise and they're going to move around, especially as alternator voltage and things are coming into the system. So you'll get a little bit of not necessarily a flicker, but like a dimming aspect. And then when you press the brake lights, you get 100%, and it goes right back to the dimming feature. But it would entirely be possible.
Certainly a workaround. Yep, certainly. Perfect. Todd, you had anything else you'd kind of like to add before we start to close this one up?
And you guys have been great. The PDM is awesome. We've used 5, we're on 6, and can't wait to build the next one because they're just a lot of fun.
They're going to get better and better too, right? Your installs are just getting better and better as you learn more, which is just fantastic. You share a lot of it, and and we all appreciate that as well.
Yeah, it's exciting.
Yeah, and I don't think there was some conversations about just getting the PDM, because it does do so much. It's a data logger. It's a power distribution module. You can record all of this information, see how much current things are pulling. We've actually found fuel pumps going bad before they left us stranded on track, because we can see the current rising in the fuel pump. So we can get ahead of these maintenance procedures before it leaves us stranded. And it all sounds amazing, but there's so much work, and we tried to hit on it, but the amount of work that goes into your planning process and your wiring installation and all of that, like making it an electronic backbone of a car, takes a tremendous amount of dedication and time, and someone who has a firm understanding of 12-volt application. So we have the data systems. They come with the stub harness. They're ready to rock and roll. You plug the sensors in, you program them, and it's lightweight. It's not race ending. A PDM, if done incorrectly, could mean that you don't get out on track.
You add so much more power, but you also add a little bit of risk there if you've done something totally wrong, obviously.
Mm-hmm. Just to add what Robbie just said, just real quick, and it'll take 2 seconds, but some of the alternators, if they cease function, they will actually go to 18 volts. And if the PDM is monitoring what Robbie said, as soon as it breaks 15 volts, you turn off the alternator. And that's what we have it doing, because in a Miata, they'll, a 2002 alternator will go straight through 18 volts.
Yeah.
It'll come back and actually blow up light bulbs. It'll fry everything in the system. So if we were monitoring the alternator the entire time we're, racing Champ Car, and if it goes above 15 volts, we just have it shut down the alternator, because it'll actually come back and blow up the battery and blow up light bulbs and everything in between.
Yeah, we have side-by-sides are really big for me right now anyways, and they have a stator. We convert them to an alternator, but we have to energize the alternator and help it get through its charging process, when to charge, when to not charge, and so we created icons on the display so that we could see when the alternator was charging, when it wasn't charging, and effectively track it. It's backed by a status variable which we record, so now we can see exactly the waves of an alternator, and the possibilities are endless. I think you said it best. It's my imagination that's a little limiting factor, not the hardware.
Yeah, I know we've added that as, that is such a true statement, and it was true even with the normal displays, especially on the alarming side, the alarms and setting up variables. It really was all into our mind and what could we imagine, and the PDM takes that to a whole new level. So very good statement. I
Should be on the
enjoyed that
box,
one.
Robbie. It should be on the box. Imagination is your limiting factor.
Exactly. I appreciate everything, guys, and all of the videos that we've done, all of these webinars we've done, plus a bunch of videos we did in the past, are all going up onto our YouTube site. This one will be up there within an hour or two, just as fast as I can do it. We've currently got about 195 of them up there, so we're building more every week. So go take a look at the YouTube site. Just go to YouTube, type in AiM Data, and do a quick search. You'll find us, and just tons and tons of information there for you. The we're not a huge company, so we're sending people out to the track every single weekend. We've got the 800 number that you can give us a call if you don't catch us at the track. Give us a holler. There's lots of things we can help you with and make this investment in your data even more valuable. So give us a holler if you need any questions. What are we doing next week? Our next webinar is going to be a Race Studio 3 analysis beta update. We should have a fresh beta for you around that time. Lots of improvements in it. I've been very, very happy. I know Emiliano has been here answering questions in the background. So he'll be joining me next week, and we'll talk about Race Studio 3 and some of these new updates, and give you some updates on what's coming in the future. So looking forward to that one. It's always great to have Emiliano here with us. So here's some contact information. We've talked about some pretty in-depth stuff. We couldn't get into some of those really super deep questions. Obviously, we've only got about 45-50 minutes to chat here, and going into the individual questions is sometimes kind of difficult, but there is some contact information. Todd has been gracious enough to allow us to share his email address, and if you have a couple of questions you might want to chat with him about his experiences with these things, they've been pretty good so far, and he's very happy with it. Robbie, of course, does these things all the time and is available to chat with as well. I, however, may not be a ton of help on this one, but I'm learning all the time as well. So give me a holler if there's anything I can do with you as well. Kind of close this one up. Robbie, you had anything to kind of add as we're shutting this one down?
Oh no, thanks for having me, and getting these questions recorded. It's been great for not only our participants but everyone else that watches them after the fact. It's become a wonderful resource for I have a problem, let me type it into Google, and our videos are coming up. So thanks for attending.
Thank you for coming here and sharing all the information. We have so many people that watch these and watch them, especially later on YouTube, and the questions are similar sometimes. And boy, it sure is nice if they can find them and at 2 a.m. or wherever they're at around this great world and find those answers real quickly. Todd, appreciate you coming. It's been fun having you as a friend for a long time, and having you finally on here. You've been on my mind to have you come on, and I was just looking for the right topic, and I'm glad we've had you here. Is there anything else you'd like to kind of add on your way out?
No, just a great company. Robbie, for 10 years, you've been awesome, and I've known you, Roger, for 20. So keep it up, and it's been a family thing. It's been a lot of fun.
The trouble is he used to always bring the Krispy Kreme donuts to the track, and that was kind of been a downfall of me. But other than that, I'll blame it all on you. Blame it all on you, right? No, I appreciate all of you being here. I appreciate the two of you guys putting in your time and helping us put out the good quality information about the PDM systems. It's been great. So thanks everybody for coming. Look forward to seeing you all here next Tuesday with Emiliano and an update on Race Studio 3 analysis. We will see you next Tuesday.